Luzon, Philippines, December 1941. On a captured airfield, American intelligence officers crawl over a prize, a nearly intact Japanese bomber. From the outside, it's a marvel of engineering, sleek, modern, with a vast wingspan promising incredible range. But as they look inside, a chilling mystery emerges. There is no armor plate for the pilots, no protection for the gunners. The massive fuel tanks are unlined aluminum shells. The initial assessment is one of confusion. Is this aircraft even finished? Why would one of the world's most powerful navies send its elite crews into battle in a machine that seems built to burn? This was the Mitsubishi G4M. To the Allies, it was the Betty. To its own crews, the Hamaki, the Cigar, or more grimly, the Type 1 lighter. This vulnerability was not an oversight, it was a calculated trade. We will now uncover the cold engineering and high-stakes strategic gamble behind the decision to sacrifice armor for unparalleled range. To understand that choice, we must go back to a single, overwhelming problem that defined Japan's military ambitions: the Pacific Ocean itself. For Japan's naval planners, the map of the Pacific was a source of profound anxiety. An industrial giant, the United States, sat on the other side of the world's largest ocean. In any future war, the American fleet would be Japan's primary target. But Japanese doctrine was not built for a prolonged war of attrition it knew it could not win. It was centered on a single, all-or-nothing concept, Kantai Kessen, the decisive battle. The plan was to lure the U.S. Pacific Fleet into a climactic engagement near Japanese waters and annihilate it in one swift blow. But geography was a ruthless enemy. To reach that decisive battle, the American fleet would have to cross thousands of miles of open water. The Imperial Japanese Navy realized it could not simply wait for them to arrive. They needed a weapon that could project power far beyond their own shores, a weapon to find, track, and bleed the enemy fleet during its long voyage. The goal was to whittle down the American force before the final confrontation even began. In 1937, this strategic necessity was distilled into a formal demand, Specification 12-She, issued to Mitsubishi. The requirements were, for the time, nearly impossible. The Navy wanted a land-based, twin-engine bomber capable of flying over 2,000 nautical miles. It had to carry a heavy 800-kilogram torpedo, and it needed to be fast as many fighters of the day. On paper, it was an engineering fantasy. With the engines and materials available, achieving that kind of range, speed, and payload simultaneously seemed impossible. This extraordinary demand landed on the desk of Mitsubishi's chief designer, Kiro Honjo. He and his team were now faced with a fateful choice. For Kiro Honjo's team at Mitsubishi, the 12-She specification was a mathematical trap. They ran the numbers again and again. With the available Mitsubishi Kase engines, the conclusion was always the same: a conventional bomber, built with standard structural reinforcement, armor, and heavy self-sealing fuel tanks, would be too heavy to even approach the required range. Honjo was faced with a stark choice: inform the Navy their request was impossible, or radically redefine what a bomber could be. He chose radical innovation. The design team began a ruthless campaign of weight saving. Every single component was scrutinized, and the heaviest items were the first to go. All armor protection for the crew, and the complex multi-layered self-sealing fuel tanks. It was a conscious, deliberate sacrifice, a cold equation, trading survivability for strategic reach. The result was a long, sleek aircraft, packed with fuel and explosives, but with almost no defense against enemy fire. The gamble was made, and in the opening weeks of the war, it would pay off spectacularly. The first test of this radical design came just 3 days after Pearl Harbor. On December 10, 1941, in the South China Sea, the pride of the British Royal Navy, the modern battleship HMS Prince of Wales, and the battlecruiser HMS Repulse, steamed without air cover. It was a calculated risk based on the assumption they were beyond the reach of any significant land-based air power. They were wrong. 85 Mitsubishi G4Ms and G3Ms, flying from bases in occupied French Indochina, appeared on the horizon. They had traveled hundreds of miles over open ocean. In a devastatingly coordinated attack lasting less than 2 hours, their torpedoes found their marks. For the first time in history, a modern naval fleet, with capital ships underway in open water, was destroyed entirely by air power. The news was a seismic shock to the Allied command. Winston Churchill would later write, "In all the war, I never received a more direct shock. The gamble had paid off." The G4M's extreme range was not a theoretical advantage. It was a war-winning weapon. Throughout the first half of 1942, the G4M became the symbol of Japan's unstoppable advance. Its long shadow fell across the Philippines, where it supported the invasion and bombed Corregidor. It struck the port of Darwin in northern Australia, a raid involving over 180 aircraft. From Rabaul, G4Ms patrolled the Solomon Islands, hunting for Allied shipping. For months, the bomber known to the Allies as the Betty seemed to be everywhere at once, a testament to an aircraft that could project Japanese power across a vast ocean theater, seemingly at will. But the pilots flying against it began to notice a disturbing pattern. In the skies over the Coral Sea and the Solomons, American Marine and Navy pilots in their rugged F-4F Wildcats learned through brutal experience. The Betty was fast for a bomber, but it was not invulnerable, and when it was hit, the result was unlike anything they had seen. A short, accurate burst from their .50 caliber machine guns, aimed not at the fuselage but at the thick roots of the wings, produced a spectacular and almost instantaneous result. The G4M didn't just trail smoke or catch fire. It often detonated in a brilliant, expanding fireball, shedding its wings and vaporizing in seconds. Among the squadrons, grim new nicknames began to spread. First, the Flying Lighter, then, more pointedly, the One-Shot Lighter. The Betty's fatal flaw was no longer a secret. By 1943, that flaw had become a catastrophe. Over the skies of Guadalcanal and New Guinea, the tactical environment had completely changed. The U.S. Navy and Marine Corps now had more fighters, better supplied bases, and superior tactics like the Thatch Weave, designed to counter the Betty's escorting Zero fighters. G4M formations were now flying into a wall of coordinated anti-aircraft fire and swarms of interceptors. The missions became a massacre. Well-trained veteran Japanese crews were sent out day after day, with survival rates plummeting to appalling levels. The bomber that had once sunk battleships was now being systematically torn from the sky, bleeding Japan's elite naval air corps dry. Allied pilots in the field knew the Betty burned. They reported it, they exploited it, and they counted on it. But the full shocking truth of why it was so uniquely flammable was only just being uncovered, thousands of miles away, by the engineers crawling over that captured airframe on Luzon. As the engineers on Luzon continued their teardown, their findings revealed a design choice far more radical than simply omitting protective liners. Mitsubishi's team hadn't just placed unprotected tanks inside the wings. The wing structure was the fuel tank. This was a cutting-edge technique known as an integral fuel tank, or a wet wing. The main spars and ribs, the very bones of the aircraft, formed the container for thousands of gallons of fuel. It was a brilliant way to maximize volume and save weight, but it also meant the aircraft's primary load-bearing structure was in direct contact with flammable vapor, with only a thin aluminum skin separating it from enemy fire. The choice wasn't just a compromise, it was a total philosophical commitment to range, accepting a level of risk unheard of in Western design. This philosophy of range above all else, and the vulnerability it created, would come to a head on a single day in April 1943 in a mission that would change the course of the war. On April 18, 1943, that mission found its target. U.S. naval intelligence had intercepted the exact flight plan for an inspection tour by Admiral Isoroku Yamamoto, the architect of Pearl Harbor. His journey was only possible thanks to the G4M's extraordinary range. But that same range put his flight path over Bougainville Island, just barely within reach of American P-38 Lightning fighters flying from Guadalcanal. The mission, Operation Vengeance, was a high-stakes gamble. 16 P-38s flew for over 2 hours, skimming the waves to avoid detection. They found Yamamoto's 2 G4Ms precisely where the codebreakers said they would be. As the Lightnings attacked, the bomber's design philosophy met its final, brutal conclusion. A burst of fire from Captain Thomas Lanfear's P-38 tore into the Betty's wing. The integral fuel tank ignited. The bomber snapped over and fell, trailing black smoke into the jungle below. The plane, built for strategic reach, had just delivered Japan's greatest strategic loss. The mystery that began on that airfield in Luzon was now solved. The Mitsubishi G4M was not a failure of engineering. It was a masterpiece of specialization, built for a single and ultimately flawed national strategy. Kantai Kessen, the decisive battle. The plan was a short, sharp war, where one crippling blow could bring the enemy to the negotiating table. In that context, sacrificing crew protection for the range needed to land that first strike made a kind of brutal, logical sense. But the war Japan got was not the war it had planned. In a protracted war of attrition, the G4M's design philosophy was suicidal. A technological marvel, perfectly optimized for one vision of warfare, had become a death trap when the war itself changed. The aircraft built to project Japanese power to the farthest corners of the Pacific ultimately became the symbol of how that power was consumed by fire.